A social occasion of the most famous researchers within recent memory uncovers something shocking. The universe doesn't have a uniform age. Rather, time elapses diversely wherever in the universe. The new pictures from the James Webb Space Telescope show up in another light, thanks to this new knowledge, and we need to inquire ourselves, what do we truly know about the universe? The revelations of the James Webb Space Telescope and the continuous cosmological emergency have once again defied our science with crucial inquiries about the universe. For just about 100 years, researchers thought they knew that our universe began from a singular point and has been growing since. This event is remembered to have happened 13.8 billion years ago. However, the great pictures and information from the new telescope have shown that there are systems that are older than the Big Bang. The Webb mission has not just caused qualms about existing models of the development and advancement of galaxies. These pictures of exceptionally old galaxies raise doubt about the whole thought of the Big Bang and expansion. Insanely, for numerous years, there have been signs that the old cosmology isn't correct, but analysts would have rather not seen it. Now they have the proof. The upsetting outcomes have prompted a meeting of leading cosmologists, high-ranking Nobel Prize winners, and the best scientists in our world who have asked themselves essential inquiries about the universe. Among other things, the role of dark energy and the unified development of the universe were discussed. Especially astonishing in this context is timescape cosmology, which gives us a totally new and maybe surprising model of the universe. Why is this so intriguing? The hypothesis is the way that the concept of time is totally rebuilt within the model in issue. Rich regions of the universe could have time elapse more slowly than in practically empty regions. This could imply that the age of the universe, as we see it, changes in different areas of the universe. Timescape cosmology, how wrong could we be? In the radiance of new discoveries, the idea of a Big Bang 13.8 billion years ago seems almost absurd. Timescape cosmology is now totally reclassifying how we might interpret existence. The central thought, that time elapses at various rates in different regions of the universe, means that the universe can't have an age in the traditional sense, and it raises the question of whether it really had a singular start. Time could elapse differently all over the place in the universe, depending on the local density of matter. In regions rich in matter, like galaxies or galaxy clusters, time flows more slowly than in practically empty cosmic voids. Billions of extra years might have passed in the voids compared to the regions with high matter densities. This actually means that the universe is old in an unexpected way, depending on the district. We might even be committing a central scientific error when we try to define the universe in terms of quantities like time, space, and matter. We could be very close to a quantum leap that not only changes our understanding of the universe, but also fundamentally restores our human life. If scientists now find that time is not direct and that our reality consists rather of spatially restricted fluctuations, it wouldn't just change our cosmology, we humans would have to face a totally new and inconsistent perspective. Imagine a scenario where we find out that such time openings also exist on our planet. Such suspicions could make sense of previously illogical phenomena, like how people such as the Egyptians had the technology to construct the pyramids. The Egyptians might have existed in a different time-space than we do today. In any case, back to the universe. The new model of timescape cosmology isn't some sort of joke by a few insane scientists. The fresh-out-of-the-box new theory is a scientifically sound advancement of Albert Einstein's general theory of relativity. The scientific genius of the 20th century demonstrated that attraction, as well as the area and development of the spectator, impact time. This all around made it clear that time isn't absolute. Einstein, indeed, even questioned that time is a real physical quantity. He saw it more as an individual experience. Timescape cosmology goes significantly further. It suggests that the large-scale structures of the universe have an impact on what we call time. In addition to making sense of the incredibly old galaxies found by the JWST, the model offers an intelligible explanation for the errors in the measurement of the Hubble constant. This value describes the expansion rate of the universe, which should really be the same everywhere. Sure, here's the passage with punctuation added. Anyway, The aftereffects of different estimation methods showed such contrasts that the error known as the Hubble pressure previously highlighted an enormous mistake in cosmology. Conventional models of the enormous bang and expansion make it basic that the universe be homogeneous and isotropic in its enormous designs, but it isn't. Hubble and now Webb show us a great many designs that are too large, too incomprehensible, and too inhomogeneous. Here, researchers saw additional proof that the old cosmology can't be steady, but it was just the phenomenal pictures from the JWST that provided the final evidence that the universe can't be 13.8 billion years old. Dull energy, a deadly mistake of science. Does it exist or not? It could never be explained whether dull energy is a reality or a fiction of science. One of the most captivating parts of the new timescape hypothesis is that it also totally reconsiders the role of dark energy in the universe. Rather than a strange, undetectable energy driving the development of the universe, the observed acceleration of expansion could be the consequence of the generally envisioned transient mutilations. The universe would, accordingly, not be impacted by a uniform power but by the intricate interactions between space-time and matter density. Timescape cosmology could, therefore, challenge all old ideas about the universe, and it doesn't even stop at gravity. Assuming we have been mistaken about the alluring power of matter, we are facing a total scientific reset. Such rearrangements are not new. Imagine how differently people suddenly needed to think when it became clear that the Earth is a circle and not a disk. Such new insights also impact our regular understanding in an interesting way. Imagine how people suddenly thought when they got it that ships could go all over the planet and not fall over an edge and be lost. Ponder that briefly in terms of time and your comprehension of the world. Imagine a scenario in which time is not a real measure, and we figure out that our universe and our Earth have different time aspects. Simply becoming aware of this reality could flip around our insight. We may suddenly see peculiarities that were previously stowed away from us, and associations in the universe would become clear that have long remained hidden due to our false perspective. Imagine a universe with different dynamic and area-dependent time circles in addition to a universal synchronized age of the universe. With these groundbreaking thoughts, timescape cosmology builds an extension to different ideas, for example, the break-the-void hypothesis, which sees fundamental building blocks for the elements of the universe in the strange vast voids inside the known universe. Voids are among the designs that demonstrate that our universe isn't homogeneous and isotropic. For this reason alone, it may be accepted that they assume a critical role in the meaning of a new perspective. The new hypothesis isn't just scientifically brilliant, it is also astounding and stretches far into philosophical or mysterious domains. Through the discoveries of the JWST, we may experience that time is actually an illusion. If time doesn't exist, how old are we? Then, the concept of time is one of the most profound mysteries of humankind and science. Time has long appeared to be pervasive, irreversible, and permanent. But imagine a scenario in which our fundamental impression of time is only a result of our situation in the universe. This question is not just raised by timescape cosmology. That time is subject to the area and development of the experiencer is known to science. Presently, we might need to expand this idea to include the thought that time is relative to the structure of matter and the universe. One of the central challenges in understanding time has always been its uncertainty. Time can be a physical amount, measured in seconds, minutes, and hours, but it can also be an emotional experience that unfurls only in human awareness. In physics, time is often described as the final aspect that portrays the sequence of events in three-dimensional space. However, this straight perspective on time is now being scrutinized. The theory of relativity already showed that time is affected by gravity. The stronger the gravitational field, the slower time passes. This result has been confirmed by experiments, like the measurement of atomic clocks at different elevations on Earth. The idea that time is affected by local cosmic circumstances, for example, the density of matter, is now an even more extreme expansion. If time relies upon the structure of the universe, it could imply that the universe exists in a consistent state of multifaceted time streams that differ from area to region. The implications of this thought would be significant. If time isn't uniform, it becomes difficult to define a global age of the universe. This would have broad ramifications for our understanding of cosmic evolution, the development of galaxies, and even the search for extraterrestrial life. Structures in different areas of the universe could exist at an entirely different pace of time, making communication and interaction greatly more difficult. However, if we could bring ourselves into the same time circle as these creatures, universes that were previously imperceptible could suddenly appear before our eyes. Moreover, we could have contact with other life forms. Philosophically, the question arises, if time isn't real and is just a concept that we use, should we continue to measure and use it? And if we do, without time, how would we sort out our daily routines in the future? Hypothetically, we would develop time-independent senses that automatically lead us to where it makes sense for the general context of our lives. In practical terms, this means that you show up at work when it's right and fitting for the universe. Our insights could open to this other form of connection, and potentially we would take a quantum leap as a species. From a biological perspective, we would then also need to scrutinize the aging of our bodies. Apparently, aging is affected by genetics, cell division, and the shortening of our telomeres. But consider the possibility that it is just the concept of time that defines our age. What might happen to our bodies if we internally leave the concept of time? We would perhaps live forever. Subscribe now, the best videos are on the way.